Hello there. We're live here at Test Containers Live, and I'm very, very happy to have another exciting episode. The sound works, the video works. I can see myself, I can see our dear guest today. Today we have Sergio from the Micronaut Foundation. Sergio, how are you doing?
Good, thank you. Thanks for having me.
Where from do you connect today?
I live close to Madrid. It's a small city named Guadalajara. There is a Mexico City with the same name, which is huge. My city is quite small, but I am like around 50 kilometers from Madrid in Spain.
Nice. Nice. This is very, very good. If you don't know Sergio, Sergio is the Micronaut development lead engineer at Micronaut Foundation. And he's also a member of a couple of boards, the Micronaut Foundation Board of Directors and the Micronaut Technology Advisory Board. So he is one of the best sources to learn about Micronaut Framework. And today we're gonna hopefully do exactly that. If you are in the chat, please send hellos, send the emojis that we cannot show on screen, but we can see them. Cedric, hello. It's very nice of you to join us. Edu, hello as well. Interesting. This emoji shows. If you have any questions, please don't hesitate. This is an interactive session, so post the comments, and we're gonna try to find the opportune moment in the discourse and talk about the topics that are interesting to you, because after all, this is all for the viewers. In general, we would like to talk about Micronaut Framework. We'd like to talk about integration tests and the Micronaut Test Resources. In the past, we had an episode with Cedric that was more than a year ago about Micronaut Framework. So now it's way overdue to take a look at this exciting project again. So without further ado, let's can we maybe catch up? Can you maybe elaborate and talk to us what are the recent big features in the Micronaut Framework releases? What are the themes that the framework is exploring? And maybe what is the general direction the project is going to?
Sure. So our current version is Micronaut 4.1.3. So we are going to release Micronaut 4.1.4 soon. We follow semantic versioning. We released Micronaut 4, so it aimed to release like a major version every year, although the Micronaut 4 took us almost 2 years. But basically, Micronaut 4 has a lot of cool features for users. Micronaut is a framework in the JVM that you can build applications with Kotlin, Groovy, or Java. And with Kotlin, we have support for KSP. In addition to KPT. So this will be quite interesting for Kotlin users. I think this is the first framework to support KSP, and this will allow compilation times to be reduced for Kotlin users. The kind of the general theme that you point me to, Oleg, is essentially the same as we always talk to, is move as many things at build time as possible. So that we like to say like this marketing phrase like stupid runtimes and intelligent build times. So we kind of generate like as much as possible as build time. So I can show you today. So when you have like a class in Micronaut annotated with that controller or with that repository, at build time will generate like extra bytecode, which lives alongside your bytecode, and it will basically allow us to know all the injections points in your application, pre-compute queries for Micronaut data, things like that. And we do that at build time. In Micronaut 4, we have exciting features at build time. For example, we support expression language in annotations. And the difference for other expression languages that you may have used in the past is that we basically evaluate all of that at build time. So expression languages have been typically a source of sometimes security vulnerabilities. By essentially moving all of that at build time, we are really excited about about that. We raised the baseline of Java to 17 in Micronaut 4. And this, so you could write, you could use a Java 17 runtime with a Micronaut 3 application. That was not the issue, but basically raising the baseline allow us to use Java, modern Java features. So for example, we have now an HTTP client based on the Java HTTP client. So we have two HTTP clients implementation now, one based on Netty and one based on the built-in Java HTTP client, which if you don't have any crazy things that you need from your HTTP client, the Java HTTP client will get you there, and your jar file will be smaller. So it's you will save like several megabytes. We have support for virtual threads as well. So if you are running your Micronaut application in a JDK with virtual threads, you can use the @execute on annotation with blocking, and virtual threads will be used. We have support for annotation-based filters, which will allow you to write filters without writing any reactive code. So in Micronaut, you can write blocking code or reactive code, but we see that more and more with virtual threads, and in general, the industry seems to be preferring, like many people, myself included, prefer like to write non-reactive code, and annotation build filters will allow you to exactly do that. Yeah, the framework is more mature than ever. Things such as test resources that you talked with Cedric a while ago is more stable than ever. The whole testing story that I think in test containers you guys are really interested in is more mature than ever. I always, when people ask me, like in Java user group, which is the best features of Micronaut, I always say that writing tests, functional tests is really fast. And I think that has a huge impact in terms of developer experience, but also in terms of the kind of applications that you produce. Because if you write more tests, the applications tend to be like you tend to sleep better at night. Let's say like that. So
yeah, that's for sure. Thank you for the shout out. It is interesting. There are a number of features, and I think I tried to keep track of the ones that you were saying. There is a lot of still going into direction of this build time compilation, what you sort of named smarter build time, and like maybe thinner runtime layer, which is interesting because the framework is actually pretty mature. I'm sure there are a ton of live production deployments of Micronaut Framework, and it's interesting that you're still finding sort of things that you can take from the runtime, that things that do not change at runtime very much, but due to their understanding, like their dynamic nature, they were always in the Java ecosystem, always thought of as a purely runtime features, and move them to compile time. Sort of, I'm personally very, very interested in the expression language. I would love to play with that a little bit later and see where it takes me. Ooh, and we have a comment from Simon that mentions that he loved seeing the collaboration with Moderna.
Yeah.
And the open rewrite, and it made the move from Micronaut 3 to 4 very smooth. Can you maybe say a couple of words about how that happened, who approached who, and what are your thoughts on the open rewrite, like for frameworks like Micronaut?
Yeah, so Modern was, I think they approached us back when we were doing the Micronaut 2 to Micronaut 3 transition. And we explored, they actually created the recipes for that. If I remember correctly, they created the recipes for the Micronaut 2 to Micronaut 3 migration themselves. When we were approaching Micronaut 4, so we have written a lot of guides and we have essentially a lot of code to update ourselves. So we said that we have to create these open rewrite recipes for helping people migrate. And we approached them. We told them that we were interested in collaborating with them in creating an upgrade recipe. The good thing about open rewrite is that there's a lot of recipes that are framework agnostic, right? So for example, with MyCode, you use Maven or you use Gradle. They have like a recipe to upgrade between Gradle versions. So we don't have to, as MyCode, we don't have to like rewrite that thing constantly, right? So we can leverage the rest. I think probably themselves or maybe Gradle created that recipe. And similar things, right? And the nice thing about Moderna is that they are quite. So it's not that we have a lot of in this transition. We have a lot of like all the industry. We have a lot of JavaX to Jakarta annotations imports, and doing those with Open Rewrite was really trivial. But then they allow you to create like custom rules. Like for example, we were able to, if the user had like a YAML configuration, we could add the snake YAML dependency to their build file. So really powerful. We have a couple of blog posts. I will paste a link in the chat with how to use that. And I think we have a couple of YouTube videos as well in our channel about how to use the Open Rewrite recipes. I am really happy about how the collaboration with them went and what we created, and I think we can improve that going forward for MyCode 5. I think, yeah, for any framework or Java library creator, it's really great. A really great way of creating like an upgrade path for user and also forcing you to create like an upgrade documentation as well. So one of the things that we saw is we were like entering in a blog post what things you had to do manually, and then we were creating issues about how to do those with Open Rewrite. So really happy about how it went.
That's great. That is, Open Rewrite is one of my favorite open source projects in the Java ecosystem. I would love to explore a couple of applications of that as well. For example, maybe to migrate from some setups for the test containers based setups. I think that could be interesting. But in general, it's a great project. Thank you for the shout out. It's very interesting to see that you're actually using that in Micronaut Framework as well, where you said that you are keeping track with the Gradle versions and so on. I don't know. I will have to check with the team. I don't know if we actually use them in test containers. Maybe Edu in the chat can provide some feedback on that. Nice, very, very nice. That is lovely. What do you have any other particular like sort of projects in the ecosystem or things in the Java ecosystem that you are sort of super excited about? You said that you can run Micronaut Framework with Java 21.
Yeah.
Would that be sort of the baseline Java version for if you would have to pick the like for new projects or?
So right now we still don't offer like so we are heavy Gradle users ourselves, and we're waiting for Gradle 8.4 release. So we are still not fully testing everything, so it should work. So what we have tested so far, it works. But what we do in MyCode is we essentially build and test with Java 17, and we will test with Java 21. And once at that point, we will offer in MyCode Launch the option to download Java 21, essentially an application configured for Java 21. What I will choose is, it depends on where you deploy. So if you deploy to a cloud runtime, which is still Java 17, something like an AWS Lambda or something like that, then I will say stay with 17. If you are like deploying in a container or in a runtime that allows you to go 21, absolutely. What we have seen, and we're upgrading Java versions, is just by updating the Java versions, you get like huge performance boost. So MyCode Guides, which is like a huge project, we We build like more than 100 tutorials with 3 languages and 2 build variations, and we run functional tests. It takes we got like a 30%, I think, from Java 11 to Java 17. I have not tried that project with Java 21, but I expect to get just performance gains. So
Right.
if just for that, I will, if you can, upgrade to Java 21, absolutely. Yeah.
Perfect. That's good. That's good to hear. Very good. Right. I think we can slowly start maybe going into the direction of the one of the main topics, which is the Micronaut test resources and how one would write integration tests uh, in the Micronaut application.
Yep.
Do you have a demo that you would like to show us, or
Yeah. I would like to show you an application that is currently using H2. It's actually an application that I saw that you originally posted in Test Container Guide. So it's I added a couple of tweaks, but I can show you to you. And then what I would like to do is move away from H2, use a PostgreSQL database. So in my code, we are quite opinionated that people should use the same database in production that they used in tests. And I will show you Micronaut Data JDBC later on that we really believe that opinion, and we enforce it in code. But I will show you how to transition Micronaut Data JP application to PostgreSQL using test containers, and then using Micronaut Test Resources. And hopefully I will be able to convey to people what essentially how Micronaut Test Resources simplifies your test code. And then we can essentially do the same for Micronaut Data JDBC.
Sounds good. Can I ask you to share your screen, please? You did it in the preparation once, but then you managed to close the tab and the setup got worked for a bit. Okay, doc. So we can see your screen now, and we can see the Micronaut Guides website and ID.
Perfect. So yeah, let me explain you the application. So this is a Micronaut application built with Gradle. We support Maven as well. This is Micronaut 412. It has so we ship. You don't have to use our build plugins, but we recommend you to. We ship both Maven and Gradle plugins. So this is using the Micronaut application and the IoT plugin. The IoT plugin is not going to be used in this demo, but just wanted to show you. Let me show you the dependencies that we have. So the Micronaut application plugin will add you some dependencies for you under the hood. So for example, the annotation processor, Micronaut inject Java, so that you don't have to add that yourself. But interesting things here. So we have logback for login. So in Micronaut, in your code, you will use SLA4j, but you will use logback typically as your login runtime. We have the driver for H2. We have Hikari for connection pool. We have Micronaut Data JPA and Micronaut Data processor. So Micronaut is a framework that we were discussing that generates out of things at build time, and we use annotation processors for that. And Micronaut Data has its own annotation processor. And then we have 2 annotations. This is another change that we have done in Micronaut 4. We default to use the Micronaut serialization, which is a drop-in replacement for Jackson data bind. You can still use Micronaut Jackson data bind if you prefer to. But here in this project, I'm using Micronaut serialization. Another thing that I have here is I have Flyway. So we are strongly of the opinion that you should use a database migration tool when using Micronaut applications. We support, I think, the biggest open source one. We support both Flyway and Liquibase. I have here Flyway. Micronaut applications, they have a main class where you just run a Micronaut run static method, and that starts the application. This is Micronaut Data JPA. So this is using Hibernate, and I am using the JPA annotations. So one table with products. The JPA annotations, you see that JPA mixes one thing that I don't like about the JPA annotations is that they mix the database schema creation with the actual annotation. So you have like here like a database schema constraint. I have a repository. This is when you work with Micronaut Data, you work with this pattern where you create an interface and we at build and we generate the implementation for you. This is annotated with repository. Here you see that the repository annotation doesn't force you to specify any dialect. You will do that later on in Microdata JDBC. Microdata JPA repository gives you like it's a parent repo which extends from CRUD repository. It will give you like some Hibernate specific things such as Flash. But essentially it's kind of what you are used to, this CRUD repository, so create, read, update, delete, so find all, delete by, etc. I have a configuration file in properties where I specify the H2 dialect, the driver, the database, the in-memory database, and I have disabled the database schema creation with Hibernate. And what I am doing instead, I am enabling Flyway, and I have two database migration, one that creates a table. Pay attention to the constraint, right? So we have a constraint in code. You cannot have two products with the same code. And then we have another migration, which basically inserts two products in the database. So far, so good, right?
Yeah.
We have a controller which does constructor injection of the repository that I showed you before, and it returns like the number of products in the database. So if I run this application with Gradle run, it should run the migrations. And if I do here like a localhost 8080, it should return 2. You probably don't see it because it's tiny here, but I have a 2 here. I output.
We see it.
So nothing fancy. This is test containers live, so we have test, and I have a test here for my controller. This is how you write a test in Micronaut. In Micronaut, the thing that I was telling you, Micronaut is fast, so we don't create slices for test where we start a part of your application. You start either the whole application, or we allow you to don't start the server part if you don't want to, or you just create a unit test. But basically, 99% of the times you will be writing functional tests end to end. So this is a JUnit 5 test. We are injecting an instance of the Micronaut HTTP client, pointing to the root of my application. I'm getting a blocking client, and what I am essentially testing here is that when I do an HTTP request against the root of my application, this is not throwing an exception. So Micronaut HTTP client, when a server responds something like a 400 or 500 or something like that, it will wrap the response in an HTTP response exception. So no exception is thrown. And then I am essentially checking that the output is 2, the same thing that we saw when we ran the application. Then I have another.
So sorry, can what I find very, very cool that how you inject the HTTP client, because I don't think I've seen that before, and that is very, very elegant, right?
Yeah.
Because if I know that I'm gonna write integration tests, and then I can inject the client, I will touch my application through HTTP most probably, so I can inject it and work with it.
So in Micronaut, we support also field injection in test, and that's probably what you often see. Like if you have like multiple tests, you could do something like this, and you could inject a product repository in the test. That's another way of dependency injection that we support in test, and you will see often. So this is another test. This is essentially testing the repo, right? So this is a test, for example, that we could do actually here, start application false, because we are not really testing the HTTP layer of the application. We are just testing the CRUD repo, right? And if I run this test, this will return 2, right? So this repo, for the Sherlock Holmes in the room, you probably have seen that this has 2 extra methods that we are not testing yet. One is basically a default method in Java, which is calling the other one. And this is using an annotation called @query Micronaut data, where you can specify that this is a native query. So this is not JPAQL. This is like a native query. And this on conflict do nothing, this is a PostgreSQL keyword is not supported in H2, right? So if I write a test for this, and I have one test written here that I'm going to copy paste. If I come here and I write a test here, the test, what's the test is doing? So it's trying to insert another product with a code that we already have in the migration that I show you here. So we already have a product with this code, which is forbidden by the database schema, right? And the Postgres syntax, what it will do is that when we try to do that insert in the database, it essentially will not crash, right? So it will do nothing. So it's trying that you invoke this method, this will do nothing, and then if I call, this thing will be empty, right? Because no insert has been done with this ID in the database, right?
Right.
So if I run this test now, the test failed as expected, and it essentially is telling us that this thing is not working, right?
Yeah.
So how can we, like, if we want to use Postgres in production because we want to support this syntax, which I honestly didn't know until recently, and it's pretty cool syntax, what can we do, right? So what I'm gonna do is I'm gonna come here and I'm gonna test it as pure test containers, right? So I'm gonna remove the H2 database driver, and I'm gonna add the PostgreSQL driver. So let me just do that. So I'm gonna come here. I'm gonna add
So this app didn't even have Postgres driver at all.
Didn't have Postgres driver until now.
So it wouldn't work in production. 100%.
It wouldn't work in production 100%.
But all the tests passed before, right? Before you stumbled on the syntax thing.
Exactly. All the tests passed because I was using this H2 in-memory database, right?
Yeah, that's amazing.
So what I'm going to do is I'm going to come to application property, and I'm going to replace all the syntax that was for H2. I'm going to replace it with Postgres. So the dialect, the driver class name, this is something that we use in Micronaut Test Resources. And the JDBC URL, the username, and the password, I'm going to delete. And I will come back to this in a second, right? So typically to connect to a database in Java applications, you often need like a JDBC URL with a username and a password. I'm going to delete this configuration for now, right? So I have configuration for Postgres. I have added the Postgres driver. I'm going to add a test container driver, right?
Yes, very good.
And I'm going to do one thing, which is I'm going to add these test containers JDBC URL. For those who have never heard about this is pretty cool feature of test containers that I typically use to start projects. Then I will move to something as I will show you today. But to get started is pretty awesome. They have like this kind of magic JDBC URL. If you search for that, you will find it. And I'm going to essentially use that in our application. So I'm going to come here. I'm going to, not in the repo one, I'm going to annotate in Micronaut. You can provide tests. You can provide configuration that is only for a test using the add property annotation. I'm going to add property, and this will essentially add like a special, it will add these two properties. So I'm going to add this driver class name, which is org test containers JDBC container database driver, which is in the documentation. I didn't come up with that. So if you go to the JDBC support, you will find that they essentially tell you that you have to specify the container database driver. And then I'm going to specify the, with this syntax, JDBC colon TC for test containers, and then Postgres and the tag of the Docker image that you want to use to start. You don't have to supply the username and password. And with that in place, if I run it, it will still fail. And I'm going to show you something that I typically, I think it failed because I am missing some dependencies still. So I didn't add the test containers PostgreSQL dependency yet.
Yes.
And I expect it to fail because I'm not running any Docker desktop or test container desktop that I will show you in a second. And I wanted to show you this because this is something that I like to do in my test. Is so you're going to have in your application, you're going to have a lot of tests which require Docker, a lot of tests that don't require Docker. And test containers has a nice annotation that you can use if you add the test container. I think it's called unit Jupyter. This one. Let me refresh. And then I can annotate this test with Micronaut, not with test container, sorry. And I can say disable without Docker true. And now if I run the test, instead of failing, it will be like skipped. It will be ignored.
Right.
Which I think is pretty slick, because that way, if for whatever reason you cannot run Docker in CI or in your computer, you can still run part of your test suite.
But you can still run part of the test. It's just particular tests will fail, no?
Yeah, but you can run like all the tests and they will all be green except those that will be skipped.
Well, yeah, but that gives you no information about the quality of your code. So it is a slick annotation, and I can imagine there are some usages for that. Personally, I would take a failing test over a skip test, because then I would at least know that it's failing. But yeah, you can come up with some setups where that could be good.
So I'm going to start a test container desktop, and I actually started testing recently with this mode, which is embedded runtime. So you see I'm not running Docker desktop in my Mac. So just test container desktop. I selected containers running locally, embed runtime idle.
Right.
So if I run the test now, hopefully it will pass.
Hopefully.
Fingers crossed. And
it will need to start the runtime. So it will take a couple of seconds in the beginning because it needs to initialize the Docker environment that is embedded in the test containers desktop. If you're watching this and you're just learning this now, this is an experimental early access feature of test containers desktop. We released that just a few weeks ago. Well, yeah, I think a few weeks ago. And then you have to enable it. So there is a documentation page that you can look at if you want to try this. But essentially, it should give you everything that you need for running test containers tests.
Yeah,
it's only Mac OS currently. And that's the part of why it's early access. So, but if you are on the Mac, you can check it out.
Yeah, I'm so far so good. Pretty happy. So I was looking forward not to have to run Docker desktop. Docker desktop is not really macOS idiomatic, let's say. So I, for one, I am really happy that you guys are going in this direction. So congratulations. So the test passed. As you saw, really easy. You passed. You essentially contribute this JDBC, magic JDBC URL test containers value for this property. And essentially, when you run the test, you see that a container is created, the migrations from Flyway are run, and we have two things in our database. And the most important things, the test that is actually testing the PostgreSQL exclusive syntax is actually being run against a PostgreSQL database and is passing fine, right?
Right.
So
and now, so the Docker container that we're using now is managed purely by the test containers driver that we use in, right? So like it's us, test containers library, managing the lifecycle of that. So we start it when it's needed and stop it at the end of the test suite, right?
Correct.
Very good, very good.
So this is how I will typically start, but what I will typically do is the following. So I'm going to remove, let me actually comment those just for archaeology, just for reference. So I'm going to comment those, and what I'm going to do is I'm going to create a container using a static and the add container annotation. So if you see, it's the same container that I used before, and I'm going to do one thing, which is in Micronaut Test, you can implement something called test property provider, and this will force you to override one method called get properties. Let me put everything in the top of the screen so that you can see it fine. When you are using JUnit 5 and test property provider, one important thing is that you do test instance and test instance lifecycle per class. And what this will allow you to do is contribute configuration dynamically. So this was contributing configuration statically. Basically, you were defining the configuration, the properties, and this will essentially allow us to create a configuration dynamically. So what I'm going to do here, I'm going to do if PostgreSQL is not running, run it. And then I'm going to return a map. So since we are Java, modern Java users, I'm going to use map off. And you see, I'm going to essentially pass the JDBC URL, username and passwords from the test containers container. The add container annotation, when you use it with a static method, as far as I understand, it will basically start the container and reuse it across all the methods. That's right, Oleg, right?
Yes. So if your test is annotated with add test containers, we're going to look at which it is. We're going to look at the fields which could be startables, which all our container implementations implement. And if that field is annotated with a container annotation, then we're going to manage the lifecycle. We're going to tie the lifecycle of that field, of that container, to the lifecycle of your unit tests, right? So if it's a static field, it's going to be tied to the lifecycle of the class. So it will be sort of started in the before all and stopped in the after all. If it's an instance field, then it's sort of the, well, the instance, a container will be created, started, and stopped per test method. I would honestly recommend starting with the class level for sure.
So I'm going to run both tests, and I expect one of them to fail because I have been ignoring intentionally. So the product controller test requires a database to be supplied, right? So what I'm going to do is I'm going to create an abstract test class, let's say, or persistence test. And I'm going to move all this logic here, right, to this abstract class. I'm going to resolve the import, and I'm going to extend here. I think you refer to this pattern sometimes as singleton containers.
In the docs, well, ideally, a singleton container would refer to the container that is only started once per your JVM process. So technically, if there are, this is not the singleton container in the purest sense, because you can have different test class hierarchies, and then they might have different containers that are being managed. But yeah, if all your tests have like a single superclass that you use, you can use that place to have the singleton pattern very, very easily.
So the test passed, right? So you see, really easy to use test containers with Micronaut. The key here when using in Micronaut is, if in order to supply a dynamic configuration, implement test property provider. Remember, if you are using JUnit 5, you have to use the test instance lifecycle per class. And then you can do anything that you can imagine. As you can see, you can supply dynamic properties. So if I wanted to, so if I run my app, right, I cannot. I will show you later with Micronaut Test Resources how, because I'm not running a database, right?
Yeah.
So I will have to supply, and I will show you with Micronaut Test Resources how that can help. Let me write one test for let me write a health. So Micronaut has a module called Micronaut Management, which essentially is similar to Spring Boot actuators. We allow you to export things such as a health endpoint or an info endpoint. So I'm gonna run the test. I'm gonna extend from persistent test. I want to discuss another thing that I think is worth discussing, which is how to essentially work so that you don't have to create a container all the time. If I want to run this test, if I do here like exchange, HTTP request, health, and I want to assert does not throw.
Should the root be the root or /health as well?
No, that's a mistake on my part. Thank you. So if I now run the test, this test will fail because essentially it cannot create a database, right?
Mm-hmm.
So this is because Micronaut see that you have like partial configuration of the database, and it doesn't know what to do, right? So one thing that we could do, and that's probably what I would recommend people to do, is migrate configuration that is going to trigger like the creation, so if I took all these properties that I took here, and I put them here, or in a different, you can create like an application. So we support environments in Micronaut as well. So you could have like an application dev for running the application. I will show you everything in a second. So if I do this, so there are times where you don't want to essentially like start a database for things that don't require a database, right? So the key of being happy is that you use test containers when you need to, right? But if you want to do like a test that doesn't require the database, so one can discuss that maybe the health test should require a database because we actually check if the JDBC connection is healthy.
But it fails without it.
Yeah, so but bear with me for a minute. So if you wanted to test something like you wanted to test so I could create a test here in the controller, right? Where I could mock the service. I could say like, you understand what I'm trying to essentially convey, right? That try to start the container only when you need it.
Yeah.
So that way, if you see like the life cycle of executing a test that doesn't require a container is going to be extremely fast, but don't shy away from testing persistence when you need to, but only start the containers for the test that require that. So this is testing with test containers in a nutshell. What did we offer to essentially simplify that? We have another module called Micronaut Test Resources, which I think was created back in Micronaut 3 probably. So it's been around for a while. It supports relational database, but not just that. We support Kafka, we support Redis, so everything that you can imagine, and it's also like extendable. So you can like supply a Docker image of your third-party dependency that we don't have any integration with out of the box in test resources. So what I'm gonna do is I'm gonna go a little bit aggressive, and I'm gonna delete all the test containers dependencies. So Micronaut Test Resources under the hood uses test containers. So I'm gonna delete the test containers dependency. I'm gonna add a plugin, which is the Micronaut Test Resources. And I'm gonna go ahead and delete all the test container related logic, right? Including, I think I have to delete the annotation that Oleg doesn't like because I removed the unit Jupyter annotation. So the way test container works is, you see, I'm gonna delete all these three, the JDBC URL and the password. The way it works is when Micronaut starts, Micronaut is gonna ask the test container server, which is gonna create a server alongside. It's gonna ask, can someone provide me like values for data sources default URL and data sources default username and data sources default password? And the test resources service is going to say, yes, I can. So I can provide you those values. I will start a container in a separate process and I will expose you these values that you basically are asking for, right?
Right.
So that's essentially how it works in a nutshell. So that's the reason that I wanted to show you first how to build this with test containers, so that what we are doing for you is actually more clear. So if I now run my test, see if it works. So you start in the containers, or the container started, it says. And now it ran both tests. So all three tests passed successfully. So this is essentially test resources to the rescue of developers. So as you see, it's really easy to essentially create like integration test without you really having to care about customizing the properties necessary to create the containers with test containers. But if you want to use a database drive, you need to use a specific version of PostgreSQL, right? So maybe you in the audience are asking you, okay, what version of PostgreSQL is test resources using, right? I want to use the exact version that I used in production. You can configure that, right? So we allow you to essentially define the image name, the tags, etc., etc. So you have a lot of. So this is not like. So we give you configuration options. That's what I am trying to say.
Right.
So I'm going to show you now a way to run this in development as well. So I'm going to create an application dev.properties. And I'm going to put these values that we have here in persistent test. I'm going to put them in application dev properties. I'm going to do that so that we start the application. I'm going to define a default environment. So in Micronaut, we support this concept of default environment. So let me actually go to the docs and pick that. I'm going to create a default environment with an application configurer. I'm going to go to my application Java. I'm going to add this. This application configurer API allows Micronaut IoT to essentially see this and understand that you are running in a default environment. We have a method to do that directly with a Fluid API when you start Micronaut, but this is what we recommend you people to do. I'm going to select development, which is dev. So when I run my application now, Oleg, we are going to see like application started in dev environment, and that's the reason that these properties are going to be picked, right?
Right.
So I'm going to run the app.
Oh, also, I can, for example, run it based on some property, right? So like I don't have to modify my actual source code to support dev or like production.
Correct. You can specify the environment that you want to run via an environment variable, for example. So you can supply like Micronaut environments dev, and that will automatically be picked.
Oh, okay. So there is even like a property already.
There is an environment variable or a system property.
Of course.
The way the default environment works in Micronaut is when no other environment is detected, the default environment will be used. Okay. So this is starting in dev, and it's happening exactly the same thing that happened in test. So you see, I don't have. So this is basically using test containers both for test and local development. So it's starting a database for local development. So if I go now to my terminal, this will be 2 as we saw before with the H2 database. So same thing. So these are the 2 things that I wanted to show you. I want to show you also using microdata JDBC, which I think is what we are more proud of in microdata. And then if anyone has questions, I'm happy to. Do we have time for me to show microdata JDBC?
Yes, I would love to.
So what we are going to do is you're going to see, and this is one thing that I want to convey to people, is microdata JDBC is going to basically give you more or less the same developer experience, but without having to use Hibernate under the hood. So that typically will result in more performance applications. So I'm going to do microdata JDBC. I'm going to, the rest is going to be here the same. In my repository, and this is something that I want to talk to you, is no longer a JPA repository, but directly a CRUD repository. And instead of repository, you have to specify the notation JDBC repository, and you have to specify a dialect. So in microdata JDBC, you cannot essentially swap the dialect. You have to go with one dialect in code. If you need to support multiple dialects, you could have multiple interface, but an interface is basically tied to a dialect, and this is the wrong autocompletion dialect PostgreSQL, right? So this is us telling you use the same database in production that you use in your test, right? So you essentially use microdata CRUD repository, JDBC repository. You can use the Jakarta persistence annotations with microdata JDBC, but we recommend you that if you go to the microdata JDBC, is that you go ahead and you use the microdata JDBC annotations, which are pretty similar to the JPA annotations. So I'm going to specify instead of entities called at entity, instead of ID is the same. And column, you don't have to specify because we really believe that you should not specify the database schema in your entities. That should be specified somewhere else. And another nice thing is, since we are like writing modern Java, let's write this with a record, right? So I'm going to go ahead and do private string. Since we are like more or less playing like the ID is not auto-generated but assigned, I could just do record product. So Java records, they are huge win. Instead of 44 lines of code, we have 8. So I call that a victory.
Right, and because we're gonna use Micronaut data, we're not gonna have those entities mutable, so we can use records without any question, right?
If you had like an auto-generated ID, like you want the ID to be, I think it was generated value, I think it's called. So if you wanted the PostgreSQL to create a sequence and give you like a different ID yourself, right? Instead of giving the ID manually, you will have to add the nullable annotation here. And essentially Micronaut will generate an ID and clone the record and insert the record. But in our scenario where I am more or less inferring that the ID is like assigned, is something that we are going to generate manually because this is the way I wrote the example, no particular reason. So we are like supplying here the ID, and in the other test that we have here, we were supplying the ID here manually as well. So because we changed for records, we are going to have to use not the getter notation, but the succinct notation. So I'm going to do here code and name. Let me see if the code compiles. So back to what I was telling before. So when you compile a Micronaut class, you see this is bytecode that we're going to generate that lives alongside your code, right? So if I now run the test, this should pass. So if you are starting a project and you want to try microdata, I will recommend you to go microdata JDBC. Is pretty powerful. As you see, the developer experience is almost identical as, so it's basically the repository pattern, right? We have also in Micronaut 4.1, we have also like a mappers similar to a struct map that will allow you to create mappings. So I see like the pattern of working with records and mapping between records is really, really nice. So that's all you need to basically transition to Microdata JDBC from Microdata JPA. So I was not using an entity manager or anything like that, so I didn't have to change any of that. If you are like just using mostly the repository pattern, the transition will be really easy.
Nice.
And that's all I had. Oleg.
Do you do and a random question which might not be relevant? Do you do query linting at the compile time?
We do. I don't know if for native query. So we do at build time. We do. So we do compile time validation. So we support like. So you see, like product has like I could create. Let me disable. Sorry, autocompile. So if I do here like so the CRUD repository has like some methods that are compiled, generated at build time for me, right? Find by ID. My class has a find by code, right? So I could do here like optional product. So optional is if the thing is not found in database, it will return an empty optional, right? I could do here like find by code, right? And do here code. And I could compile this now. And Micronaut data should be able to compile it fine. If I did find by código, which will be code in Spanish, right? And I compile this. So I just create the classes, right? I have just compiled application. Micronaut is going to tell me like unable to implement repository method, cannot query the entity product on an existing property. So Micronaut data at build time will try to, this is important because it will essentially, it creates like an earlier feedback loop where you catch the errors earlier, right? So
no, absolutely.
Unless you really need to do something like you really like to write a native query, what you will find yourself is like writing this kind of so you could do like find by code and ID or things like that, and that would be valid syntax in Micronaut data, right? Yeah.
Okay. No, that's very, very cool.
Because it's long.
Right. And then there is a question from Simon. Micronaut data is reflection and runtime proxyless. If I recall correctly, is it right?
Right, yeah.
Okay. Okay. Very good. Oh, I see Cedric also responded to the comment. Thank you for the questions in the chat, and thank you for sharing the information in the chat as well.
So if you allow me to show something, so we were like saying like let me see if I can open here terminal. If I do here, if I select within the, if I select here like Oracle GraalVM JDK, right? I could do here like Gradle native compile, native test, sorry. That will run, this is because we are using JUnit 5 and JUnit 5 integrates with the native test. So I could actually generate like, I could run like my test against the native image. This should all work because this is all completely reflection free and GraalVM friendly, basically.
That's amazing. So, and it will reuse the infrastructure, right? So the sort of
it will create. The nice thing about Micronaut Test Resources in relation to GraalVM native test is that Test Resources essentially creates like a separate class path. So we are using test containers under the hood, and test containers I think is GraalVM friendly. But if we're like using something that is not Graalvm friendly, right? Because you wanted to use, I don't know, like I to be honest, I don't know if local stack is like Graalvm friendly. But if you are using something that is not Graalvm friendly, but you had it in the test containers class path, in the test resources class path, right? It will essentially not pollute your test, right? So because
Right. Yeah.
that's a completely separate class path for native tests.
Right. Exactly. So yeah, and that is a separate class path from your sort of the production class path, so it also doesn't pollute that. And nice. Right, and then
So the test is just finished and passed, and somewhere here we a lot of bouncy castle warnings, but apart from that, the containers were basically created here.
right. So the containers were created very early when you run the tests in sort of on the JVM, and then you build the native image. The containers were still running, and then you run the tests in the native image mode, and then it reused the same containers.
Yeah, Micronaut Test Resources allows you also to run like the test resources server and leave it running so that you don't have to turn down the container each time. So you could do like, if I open here my Gradle drawer that I like to call here in IntelliJ, there is like a group called Micronaut Test Resources where you can start the test resources service, and that will be essentially on the background running. So that will basically create like a faster feedback loop.
Right. Nice. That is pretty amazing. That is pretty amazing. I like it very much. It's a very elegant implementation. So I think it's very enjoyable to work with.
Yep.
Right. There were, I think we don't have any particular questions in chat. I like this very much. Thank you for using Test Containers Desktop and the embedded runtime, early access embedded runtime.
It worked flawless. You saw in the demo.
It still works, right? Like it's started
flawlessly.
It's actually pretty powerful. I think I once forgot that I'm running that instead of some other Docker environment, and was running like Minikube local Kubernetes with the Docker driver, and it was using that and running containers, and it all worked.
Yeah.
Before I messed something up myself. So that is very, very cool. Nice. Thank you for this demo. It was
My
you
pleasure.
covered quite a bit of ground. We started with the simple Micronaut application that was using H2. Then we removed H2 because it didn't allow us to run some tests. Then we figured that we didn't have the actual production database driver on the class path and made the application production ready. Wrote some tests, explored test containers, explored the JDBC support for test containers, the configuration, dynamic configuration in Micronaut was test provider.
Test property provider, yeah.
Test property provider. And then moved to using test resources, Micronaut test resources for creating the environment, and even use that for Graalvm native image compilation for the test, which is very, very cool. Thank you very much, Sergio. We are at time. This was a pretty amazing show. Thank you so much for coming. Thank you for sharing your knowledge about Micronaut Framework. It was very, very good.
Yeah, thank you very much.
All right. There are no questions in chat, so we're going to stop the stream. If you're watching this on YouTube later, smash all the buttons, as they say, and subscribe. We're going to have more shows coming. I think they're going to be pretty interesting. Thank you very much. Thank you, Edo, for being with us and watching, and for kind of feedback. So it's all good. Thank you very much. See ya. Happy testing.